Good morning, everybody. Today is August 17th, and this is the CAPN office hours. As always, this is posted to YouTube within a day or so after, and the links will get posted into the agenda doc if you want to come and catch up on this later. Say anything you don't want to be posted to YouTube and broadcast to the entire world. And I think we can get started. Charles, I think you're the main agenda item for the day. If you'd like to take over and start talking about your updates. I will be honest and say that I have not gotten a chance to actually read through it yet. So giving a summary would be really useful for at least myself. And then I plan on getting to it today from a review side of things.
Yeah, that's okay. Yeah, so right, I wanted to discuss the proposal, the enhancement proposal of using the cubeadmin to do the templating, because based on what we discussed last time, we may have some improvement, I will say. So I changed part of the proposal and I will just go through the doc quickly. And if you guys see anything wrong, you can just correct me. And also I'm still working on the code, but the code will be very similar should share the same idea as the proposal. So yeah, I think it will be helpful if you guys read this proposal and then reading the PR later. So I will go into share the screen.
Give me 1 second. I think I need to give you access. Co-host. All right, you should have access.
Yep, I got it. So, yep. So could you see the proposal?
Yeah. Yep.
Using cubeadmin control plan provide for CAPN. So I will not repeat the section before the proposal. That was the same as the old one. I will just go through this part, the implementation, and I redraw all these figures based on our discussion last time. So a little bit recap. We wanted to have, so instead of importing the cubeadmin library or copy the code into our repository, we wanted to just using the cubeadmin executable to call the executable during the runtime and generate the manifest, because that can help us to initiate the manifest and also can help us to update the manifest. So here is the updated architecture framework. So on the left-hand side, we have a container. This one is actually the, and also this one I mentioned about nested machine controller and instead of the nested control plan controller, because I think at the end of the day, we wanted to use the nested machine controller to replace all the nested control plan, nested API server controller. So this graph is for the final state. But in the PR corresponding to this enhancement, I will not implement the nested machine controller. That will be in another proposal and another PR, but I will just use the final state to explain the idea. So on the left-hand side, we'll have a container here. And inside the container, we run a nested machine controller and also a cubeadmin executable. We will bake the cubeadmin executable into this container image. And once we start this container, we will have the nested machine controller running with a container that has the cubeadmin executable included. So the whole process will be the cluster admin will go into apply all the CRD, the nested machine template CR, the nested cluster CR, and the cubeadmin control plan CR. And then we have the cubeadmin control plan controller. It will detect that the nested cluster CR is ready. And then it will use the nested machine template CR to adopt the nested machine CRs. Here, we will just simply create nested machine CRs. And then we will use the cubeadmin control plan CR, because inside the cubeadmin control plan CR, we will specify a fields. The fields including the cubeadmin config. So a little bit background is when we start the cubeadmin, if we are using the cubeadmin to provision a Kubernetes cluster, the user can pass in a configuration. That configuration file can including like the command line argument of API server, controller manager, and ATCD, something like that. So in our implementation, we are going to rely on the kubeadmin control plan CR, and we are going to use the kubeadmin config included inside this kubeadmin control plan CR. So so the kubeadmin control plan controller, this logic has already been, I think it's already been implemented inside the current kubeadmin control plan controller. So it will extract the kubeadmin config from this kubeadmin control plan CR and use this kubeadmin config, attach it to the nested machine CR. Here we assign the kubeadmin config to a corresponding nested machine CR by set the object reference inside a nested machine CRs. And then the nested machine controller will detect that the nested machine CR is ready because this nested machine CR has the kubeadmin config. And then we will use this nested machine controller to, inside this nested machine controller container, we will then call the kubeadmin executable. We will fit in the kubeadmin config into the kubeadmin executable to generate the manifest. So kubeadmin executable is very convenient. You can just run the kubeadmin initiate, and you set a phase as control plan, and you specify the components you can specify the target components, and then a kubeadmin will help you to generate the static part manifest and start it under the etc Kubernetes manifest directory. So we will rely on this whole mechanism. We will just use the kubeadmin config to generate all these static part templates. And since the nested machine controller and the kubeadmin executable, they are shared a container, so they are shared a file system, then the nested machine controller can read this manifest from the container's file system. And we are going to use this manifest, static part manifest, to create nested component parts. So here is another change. We are not going to create stateful set. As Chris suggests, we can just create a nested component parts, because that can enable the kubeadmin control plan controller to help us to manage in the life cycle of the nested component parts. Yeah, so that's basically the whole process. You guys have any questions or comments?
Yeah, I have questions is all this interface like nested machine template CR, I believe nested cluster CR is our CR, is created by us, right? It is Capian CR. And I believe KDM control plan CR is upstream CR, right? So we are not going to change that.
Oh, no, yeah, it's upstream CR, yeah. And the machine templates, I think it's also upstream CR.
Upstream CR, okay. KDM config CR is upstream CR, right?
Yeah, yeah.
How about nested machine CR? Is upstream CR or our CR?
We are going to create our nested machine CR. Define our own nested machine CR.
Yeah, yeah, I think workflow wise is kind of straightforward, but I only have some suggestions about naming. I'm not sure, because if upstream there, if there are upstream CRs, we probably can keep the naming because we are not supposed to change it. But for internal like nested machine controller or nested machine CRs, maybe we can find a better name, because we don't have any machine in fact. So it's just my suggestion, because I'm just trying to, there's one level of abstraction here, is like we are not leveraging real machine, so we just
correct. So the machine things here is because we are following the upstream convention. So every provider, they have something like a machine CR, even though we do not have the actual machine here. But I'm not sure.
That I understand, because that is from user facing perspective. You have nested machine template CR. Oh, is nested machine CR also a standard? I thought it's just an internal thing. It is a standard.
It is a standard, yeah. There's vSphere machine, AWS machine, Azure machine. In all the other providers, because they're actually machines, there is an actual CR for the machine that's generated based off of the Cube ADM config and the nested machine template.
Ah, I got it. Okay, then this is also upstream CR then. It is?
It's your implementation of the it's the nested implementation of the standard.
Ah,
Exactly.
so
Right, there's the implementation because, like, for example, vSphere, for sizing, you give it amount of CPU memory disk. For AWS, that's going to be the size of the node, T2 small, whatever, it's going to be there. So that's the infrastructure specific configuration
okay.
needs to go into there.
Okay. So basically the convention is that you need to have a CR with suffix name machine.
Exactly. That's the standard is machine and machine template, which generates the machine. Yeah.
Interesting. Nested.
Yeah, it's a little bit confusing because I think our implementation is even more confused than the Docker provider, because in Docker case, they do not have a machine as well. They create a container as a machine. But in our case, we don't even have a container. We're just
I suggest
Yeah, we just have a virtual object that we're representing that does not actually exist.
so that I would suggest maybe change the prefix, so nested, because we can change that, right? So it doesn't have to be nested.
I think it needs to follow the standard of what the name of the project is. And so I'd have to go through like a whole process of trying to change the full name of it.
Yeah, I don't know. I'm okay with nested cluster. That's fine. I'm very specific to that machine because can we just don't call this nested machine? I don't know if virtual is a good word.
It would get really confusing because what you end up doing is when you write your template, you define when you write your template as well as, well, everything has to is represented based on the infrastructure ref from the actual cluster itself. And then when you build out your nested machine template, we would have inside that object a nested machine spec that you're actually representing, or your defined line that it's actually creating. And so you want to keep everything consistent between all of them. Which I think we can basically probably solve. We could potentially solve that with like with documentation about what it's actually representing behind the scenes, since it isn't a real physical machine, although it represents a collection of resources, which is I think where it gets really confusing, because each machine represents one API server, etcd, and controller manager deployed together, although they are deployed independently of themselves. Yeah. It would be nice. I kind of wish we did have the virtual name in here. The pushback and conflicts that we had when we were basically getting the project created was that it felt a little bit too abstract for what it is, and the other side of that was cap V was already taken by vSphere as well, and so the suggestions basically came from what else can we do that represents more how it's architected versus what it is as an abstract term.
Nested machine template.
I wonder if it really, since the little side of me kind of thinks like we could definitely bike shed on it. I think a little bit of this is stuck with the naming. And I think I think most part users aren't going to directly manage these for the most part, or sorry, create these for the most part. They're going to be using cluster_ctl to basically do the cluster_ctl generate all the manifest into a single directory. If they need to go tweak things, they can go edit those files that it generates, but at least from there, everything is pre-created for you. And so they won't technically be like, oh, let me go write this new nested machine template control, like CR, and get all confused on it.
Exactly, yeah. The basic use case of the nested machine is that in the end, the core machine object in CAPI needs two references. It needs an infrastructure ref and a bootstrap ref. So the kubeadm config is what goes into the bootstrap ref there from the core CAPI machine controller, but it needs an infrastructure ref as well, and that's where the nested machine CR is, which could be, except for I think the contract in Cluster API has a few fields that are necessary there. But except for that, which are basically like status ready, I think. But except for that, there is nothing that actually needs to be in that CR. It could be a pretty empty CR with a very minimalistic controller around it as well. Just to meet the contract of an infrastructure reference.
So can kubeadm support to install two control plane in one node?
No, it'll be one control plane per node.
Per node, okay.
Yeah, so we'd represent, so when you do cluster cuddle and you define like control plane nodes, that's gonna template out three, or the idea there is it's setting the nested machine template, or no, correct me where I'm wrong. I'm actually not sure the physical resource that it actually updates, but basically the idea there is that sets the entire cluster to have three nested machines for the control plane pods. I don't know what resource that actually gets defined on. From a templating side of things, though. Scott, you probably know.
Yeah, the kubeadm control plane has a replicas field, and that replicas field will be how many machines and how many kubeadm configs are generated based off of it. So it just has a replicas field that then will define how many machines and kubeadm configs are generated accordingly.
Okay, yeah, I think if the convention is we have to fix the naming like this, yeah, I'm okay. It just we will have a hard time to do the documentation, probably explain what this machine mean. This is how can we explain this? This machine is.
We basically acknowledge that it's that a nested machine, because I mean, the hard thing is because we have virtual cluster that has that as a naming scheme. We also get into a place where nested and virtual in our world are synonymous with each other, and so I think we basically just have to call it as that, and basically say when you're in this world, the control plane nodes are virtual instances that manage a collection of resource that run the cluster.
So the machine is just a collection of resources for the control plane. So
yep.
Yeah. Okay. Yeah, it seems like this way because normally it is. Yeah, because in VM world it make more reasonable because each machine is just VM. So, but in physical world, it's not that. Doesn't make that doesn't that make sense because it's a full node. Full node can be really big if for the bare metal machine, but I doubt people will use that way. Yeah, I'm okay with if it is naming has to be like this.
Yeah, and I think it also makes possible sense, especially if it's moving away from stateful sets into pods, that what the reconciler of the nested machine would do is check if the pods exist in other ways, otherwise recreate them or whatever. Because a pod, if someone goes into the supervisor cluster and deletes the pod, what the reconciliation of the machine would do is generate again that specific pod spec, right? Because you don't have any abstraction at the Kubernetes level recreate that pod for you because there is no higher level controller above it. So this would be a higher level controller of pods in sense.
Yeah, that's okay. I think that's okay.
And this is also what provides us the abstraction. Oh, sorry, go ahead, Faye.
Yeah, how about the naming? Because Stephen said that they have a specific naming for that, but for the control plane pods, what would be going to be the name for that pod?
They'll have to be the same scheme that's used by the rest of the cluster because of how the health checks work. And at the end of the day, one of the things that the nested machine has to represent for us is the way to access. Wait, actually, never mind. Sorry, it doesn't go through the nested machine. Ignore me. But the naming will have to be the same sort of scheme that represents the actual node, the node that it belongs to from a resource perspective. And then that is represented in the pod name for each of the API server controller manager and etcd.
Yeah, how about the service? Which part controls the service creation? Nested machine controller?
That's a good question. Charles, do you have thoughts on that?
I think we can add the nested machine controller to create a service, because right now we have the nested, I think nested API server will create a service for nested API server for an API server. So since we are going to remove all this nested component controller, so we can move this functionality into the nested machine controller.
Wait, Scott, there's also, so V1 Alpha 5, there's a new resource, right? The load balancer, the control plane load balancer resource or something like that we can probably rest on later. Correct me if I'm wrong.
Yeah, so V1 Alpha 5 is going to add in another type of provider, which is the load balancer provider. The current thoughts on that is that they're going to attempt to implement the gateway API, the new gateway API in order to implement that. But basically, it's going to be a pluggable way of changing what the load balancer is going to be. So that could be a service type load balancer. That could be an NLB, ELB in AWS, or Avi or NSX in vSphere, or whatever you would want it to be. Currently, the way that most implementations are done is that it's done at the infrastructure provider, and that in the end, the control plane endpoint, which is that service IP, is set in the nested cluster CR. So that's set in the vSphere cluster CR, for example, and from there into the cluster itself, basically into the cluster CR.
That would make sense, because we also need to make sure that we have represented all of the IP SAN, or all all of the different ways to address this for certificate management. So having it in a single place that's not in because we will potentially have multiple, or you could deploy a 3 virtual machine control plane, or sorry, 3 nested machine control plane. Doing it in the nested machine might be overloading it, and we could potentially abstract that one layer higher in the cluster, like how the rest of the folks are doing this, and then rest on the load balancer provider. And just to make sure, the load balancer provider isn't actually supposed to conflict with the out of tree cloud provider implementations of load balancers. This is specific to the control plane load balancer, right?
That is correct.
Okay.
The reason that it is specifically being built that way, that it will target machines as its endpoints, the reason for that is because basically the typical way of doing a CAPI install is that you bring up kind on your cluster, you create you install the CAPI provider, let's say Kappa for AWS, you then create a Kappa cluster, install Kappa on that cluster, which was a workload cluster, and then do cluster cuddle move to move the management of itself to itself, kind of. But the basic issue is, like, kind doesn't have the service type load balancer implementation of AWS in it. So because of that, it needs to be decoupled away from the service type load balancer implementation in the management or supervisor cluster.
That makes sense. Yeah, that makes sense. Okay,
right?
so
And
no
in
conflicts
general,
there.
and in general, the service gets created as the first thing before even moving on to creating the control plane or anything like that, because kubeadm will require that in order to generate the SANs.
Gotcha. Okay, there you go. So we do that at a higher level in the nested cluster for reconciliation, for creating the service And then we
And then at
pass
the
that
nested
down.
machine, and then the nested machine, you would add the endpoints into the service, basically.
Gotcha. There you go.
So are we going to do this way? So we are going to create services in nested cluster CR then.
That's what I would say at least.
Okay.
Charles, I'd rest on you as well for that.
So, wait, so we are going to create a service inside the nested cluster CR, right?
Yeah, that's at least what we're talking about.
Okay,
And then update the endpoints in the nested machine CR for that service.
okay. Oh, okay.
Oh, that makes sense because then we're manually manage. Oh, that's interesting. I wonder how that cause any conflicts. There was that most or like a recent CVE about being able to update endpoints, and the remediation as far as I know is to basically restrict people from being able to edit endpoints. So that would be that'll be interesting to see what security says about that, or what different levels of security say about that.
I think
if we go
technically the way you could do it is not through endpoints. It could be through patching the pods and adding a label to them. And then just have the service with a label selector, basically. And then when you add the label, that in turn creates the endpoint for you, but in a secure way.
Yeah, that's
yeah,
because again,
centralizing.
other-
I like that idea. That
That's
makes a lot of sense.
that's my thought.
Right, because
We should just,
yeah,
just use the label, just use the label, add label to the pods and automatically create endpoints. So that's my feeling.
Yeah,
exactly. And
Go
the
ahead, Trey.
other thing that moving to pods helps with here is that you can generate the names with like a UUID at the end, and then that will help you down the road with upgrades because you're not stuck with the stateful set naming of 0, 1, 2 anymore. So you'll actually be able to down the road implement in a better way upgrades of clusters because the naming convention isn't hard coded anymore.
Oh, I like that. It's a really great idea. So the idea there is the naming scheme has some sort of like hash in it that we can represent based on the machine, which means it makes it really easy for us to recreate machines and not have to tear down a pod before we recreate the same resource.
Right. You create a new etcd pod, join it to the etcd cluster, and then delete the old one, basically.
Nice. Yeah, I like that. That makes sense.
And yeah, and the only thing is the name of the pod will need to be the name of the etcd minus the name of the machine, or Cube API server minus the name of the machine, because that's how KubeADM is going to, and the core controllers will validate that etcd is healthy, for example, by checking the pod that way. And it does it by naming of the component minus node name.
Ah, okay. Yeah, that makes it much better, much better. Because then we can name them whatever we want. We can yeah, I like that approach. I thought we were stuck with like the 1, 2, 3, 4s, like an incrementing index. I'm glad to hear that we technically don't need that. It just needs a machine name.
Yeah, that was only needed when we used the stateful set approach, because that was at least a way of making it standard. But here we have a way of doing it as well.
So we have the pod name set by the KubeADM executable, because I thought it's the static pod manifest should include the name as well.
So the KubeADM config has the node name, I believe. And then from there, it generates the pod name. The KubeADM config, whatever, can then generate the pod names of the static pod based off of the name that is provided within the KubeADM config, basically.
Oh, okay. Yeah, I think Charles can just give a try to see what name they introduce. So I'm guessing it's just follow the convention that people were saying, like machine name minus a UID kind of thing.
Exactly. It's similar to like deployments, because the general way of looking at it is it's like with worker nodes in the other providers, there's a machine deployment, which creates a machine set, which creates a machine similar to like deployment replica set pod. So it ends up being with like a machine in other providers is like the cluster name minus MD0, let's say, for machine deployment 0. So that would be the deployment name. And then it gets the replica set ID, so the machine set UUID, and then the pod/machine UUID after that. So it's got like 2 IDs after it, kind of, because they kind of replicated the deployment replica set pod methodology there as well. And Cube-ADM control plane works pretty similarly to that as well, at least in naming convention it does.
Awesome. Yeah, I'm sure they're leveraging just like the generate name field to generate a lot of those as they nest that down. Cool. I like this. This sounds fantastic. Makes it so like the strategies long term is going to be much better here too.
Yeah, so there's one more thing. So Charles, I don't see in this figure, I know it should be somewhere, but how do you see, cert manager, the certification parts, is all handled by the controller, or we already created beforehand? It's kind
of. Certificate manager, I think we will create it beforehand. Before we apply all the CR, we're going to create a certificate manager as well. It will generate all this certificate at the same time.
Oh, okay. So this is just a part of the workflow. So for the entire workflow, we will have a kind of a few more.
Right. I didn't including other components.
Okay.
Yeah, try to make it straightforward. Yeah.
I see. So the KDM config CR should, so where do you input the certs? I'm just curious. Should it be KDM config CR?
Config CR. Which one?
So
this one?
Where do you put the certs or all the certification? Where do you put? There should have to be input.
It's based on a scheme. So it's a common scheme for all of the resources, and it's just going to mount secrets based on the name of the resources.
I see.
And so it follows. There's a doc on CAPI's website that basically defines where to get where to get the CR or the CAs for etcd, the front end proxy, so on and so forth. And it's just a common scheme that the cert manager resources, certificate resources, will have to represent, and those will get generated out of cluster, and then it will do some checking to make sure they're there. And then a future improvement we can probably do there is adding back in the code that we have currently in place to generate them if they're not found, so that if somebody isn't using cert manager, which out of the box you're supposed to with CAPI anyways, but at least we'll have backwards compatibility so that you don't have to, and it will generate self-signed certs if you don't provide anything. Those functions are pretty easy to leverage, because there's like I think there's basically save or generate for the certificates, or fetch or generate. I forget what the function is.
Okay.
Yeah, KCP will generate them for you if you don't have them in the naming scheme in advance, basically.
Yeah, that's right. I forgot. I pulled that code from from KCP. So yeah, that is how it will be done. Thank you.
Yeah.
Yeah. So will any of this CR needs a webhook?
Yes. A lot of them are pre-set up for you from the Cube-ADM side of things, and then we'll probably have some for validations over time. But the CAPI stuff has some built in. They got get audited.
Okay.
Yeah, there are a bunch of validating CRs for mutatable fields and immutable fields, and because certain things cannot be changed today. So like changing the control plane endpoint is not possible in CAPI today.
Okay.
So like that is a immutable field, but there are mutable fields as well. So there are validating webhooks in the Cube-ADM Bootstrap provider and Cube-ADM control plane provider that do that already. They come out of the box when you instantiate CAPI.
Okay. Yeah. I don't have any questions.
And Charles, one more question from my side, something that had come up in the last meeting as well. what's the plan in terms of different KubeADM versions? Meaning if I wanted to have nested clusters of multiple versions, is it going to be a single pod with KubeADM in it, which then limits the skew of clusters, or is it going to be a pod per cluster, which had come up last week? Like, what's the idea there in terms of KubeADM versioning?
I don't have any preference right now. I think I will just put all the version of KubeADM executable into the containers, maybe. Chris, do you have any suggestion? Maybe we can have, for each version, we can create an independent container. That can be another option, yeah.
I don't have any hard line thoughts there, other than I think either path works. I slightly would be concerned about packing everything into one, like all the different versions we support into one. It would be nice if we had like golden images that we could use for, this is KubeADM for 117, 118, 119, like separate images. And it's just the job that gets kicked off, since the control plane components have to, or not the control plane, sorry, the cluster components have to kick off the job itself, meaning we have to have a pod manifest that's going to go and generate all of these things, that generates the machine and so on and so forth, and runs KubeADM. We can easily template out and say, use this image for this version of KubeADM because you supplied this version of Kubernetes. Like, that matrix shouldn't be too crazy. Just making sure we have some automated way to build those is what I think is most important. Because if we have the KubeADM binary, as well as we need the machine controller binary in the same instance that gets kicked off, that starts everything, or that creates
Correct.
the resources and uploads it. I think as long as we have a way to pack everything together and we have a single Docker image that's pushed somewhere, I think that's fine per instance, per KubeADM version.
Yeah, this remind me another topic. It's like, are we going to support multiple version of control plane on top of one management cluster? So for example, the management cluster is 1.18 and the user may wanted to run 1.16 and another user wanted to run 1.17. Is that a case? Are we going to support something like that, or we only allow user to create the same version as the management cluster?
Which that may not always true, because creation is just one part. So for upgrade, you cannot probably you cannot force everybody to upgrade. Maybe you can. As long as you are not forcing everybody to upgrade, you will have a mix of different versions anyway in the system. So that's exactly the question. Is you probably have to think about the case that you need to manage different versions. The question,
Scott, can you have in CAPI core, does it matter if you run the control plane components or the entire like infrastructure and all that components on a different version than what you are creating? Is there a standard there? I haven't looked into that.
So there is workload clusters can be any version that is supported within that, that is supported by that version of CAPI, without regard for the version of the management cluster. Again, here it becomes difficult because in the end it's running on the same resources. So if something were to change in pod specs, for example, if all of a sudden that moved to Core V2 and there was some change there, which obviously is not happening now and hopefully won't happen, but if something were to change in that, that could become an issue for CAPN to support something like that, where there would be a breaking change. But currently, like for example, you can have a management cluster that is 120 running 119, 121, 118 clusters freely. There's a minimum version for a CAPI API that the Kubernetes cluster of the management cluster can be. And then there is a skew of what the supported workload cluster versions are for that CAPI API version. So like
Okay.
V1 Alpha
But I mean, yeah, it
3
sounds
can-
like, yeah, go ahead.
V1 Alpha 3 cannot support 122 as the management cluster, but can support 122 as a workload cluster. V1 Alpha 4, I think, requires 120 or above as the management cluster, but can support 118, for example, as a workload cluster.
Yeah, I think we're just gonna have to draw out some matrix for this and focus on being that n+1 on either side, or
Yeah.
n plus or minus one, and just basically say we have a little bit more policies around this because of the way that it nests and the workloads get scheduled onto the management cluster. I think it's just something we have to manage and define what we want there.
Yeah, that's okay. So, but I actually my concern was that I understand that the management cluster has version requirement for the running the entire thing, but I was thinking more in the sense that how this machine controller interacted with the kubeadmin executable, because kubeadmin executable is not backward compatibility, is not backward compatible, right? So it may generate part YAML for 118 for one YAML, even for the same configuration. When we move to 120, the YAML may change. I don't know if it changed or not. So if we want to do upgrade, so supposedly if the upgrade is handled by the nested machine controller, it needs to talk to different version of the kubeadmin executable to generate different YAML, right?
Yeah, kubeadm is tied to the Kubernetes version. So
So
when you want to upgrade a kubeadm cluster today, you do an apt update for kubeadm to the version that you want, and then you can generate the manifests and upgrade to that version.
yeah, so that means if you want to handle, if we nested machine controller need to handle the version upgrade, it has a way to access multiple versions of kubeadmin executable. So that's the reason I was thinking we probably the easiest way is to pack everything in one container. Otherwise, I don't know how this upgrade workflow is going to be. How the nested machine controller has a reliable way to access old version of kubeadmin executable.
I think only other way, there's only one
ahead.
other way, which is that at the nested controller, you would create a pod for that cluster. So there would be, just like you're creating etcd API server, all of that, you would create a pod that you would have a Docker repository or whatever. There would be a field of which repo to pull from. So if someone was pulling it from an internal registry or whatever it is, but basically it would have a naming convention of capn kubeadm and then tagged V118, V119, V20. And then you would basically create that as another component for the cluster, because the issue with baking it all into the machine controller also is that if you release it right now where 122 is the latest release, when 123 comes out, you'll need to release a new version of CapN to support that, versus if there's no breaking changes, just create a new Docker image with kubeadm of that version, push it to the registry, and it'll work.
I see. It should work. Yeah.
This will be much easier, I believe, also in hopefully 123, 124, when ephemeral containers are moved out of alpha state, because then it's possible that you could just create ephemeral containers, which was added as alpha in 122. But this could be an interesting use case for ephemeral containers beyond debugging, creating ephemeral containers of kubeadm at the right version via a controller.
That's
But that's
fascinating. I didn't even
alpha
think
now.
about that. Yeah, because you could do it
It's
into
alpha now,
itself.
so you
Yeah.
exactly. You're alpha right now, so I don't think you want to. I mean, it's alpha right now in 122, so I don't think you want to require a feature gate for CapN right now. But that could down the road be something that would be very interesting as a topology for this.
Yeah, that's a fascinating idea. I hadn't even considered that. But yeah, definitely agree. Don't want to bake that into the initial release of this. If we can use something, if we can kick off a job or kick off another pod that does that, like basically an admin container that does a bunch of operations and then shuts down for the cluster, and we do the exact same thing for every single machine of it. that goes and creates every single manifest, saves it, and then something else applies it to the cluster. I think that would help towards the future and also solve our current problems.
Yeah.
Okay, so I guess we are on the same page, right? We are going to bake the just one version of Kubi 8am executable into the container image. And for
Yep.
each version,
we'll have
we're
one
going
each.
to have an independent image. Yeah.
Yep.
Okay. Okay.
I like
so,
that.
yeah.
Nice work on this doc. I'll give it a read and I'll give it some comments this afternoon if anything else comes up. But great work.
Okay. Okay, sounds good. So at the same time, I'm working on the code. Mhm.
Cool. How's the code going? Is it a crazy mess, or is it feeling like
No.
it's not too bad?
I think it's better. It's much better than just
Awesome.
copy the function into the repository. Turn out to be we copy. Finally, at the end, I copied the whole kubeadmin directory, almost the whole kubeadmin directory into the Kappan. Yeah.
Oh wow.
So it's
Yeah,
much
that'll make-
better. Yeah. Mhm.
Very, very cool. How far? Just out of curiosity, no pressure, but do you think you'll have something demoable in the next couple weeks so we can actually check it out and try
Yeah, I
it?
think so. Yeah, I think so. I think I can do a short demo next week.
Awesome.
But I'm not going to do the nested machine controller, right? I'm still using
Sure.
the existing implementation, and we will going to do the nested machine controller in another next PR or next Kappan enhancement proposal. Yeah.
Sure. Cool. That sounds good.
Okay.
All right. We've got 10 minutes left. Is there anything else anybody wanted to bring up before we call this for the day? Awesome. All right, everybody, you have, oh, go ahead, Faye.
One more thing is, yeah, I think I missed this PR, but since there is a PR about add framework for E2E test preparation.
Yeah, I just started taking a look at that. I missed it as well until this morning when I went back in here. There's one other for the non-root stuff. If anybody wants to look at either of those, I'll happily take some eyes. Otherwise, I'll try and get to those today.
Yeah, so for the E2E test, let me see.
So there's a whole framework for what we're trying to do there that follows the same pattern as all the rest of the CAPI providers, and so we'll get some cross-pollination from what other folks are doing, and I think that's what.
That's actually my question. So do we have CAPI? Does CAPI has standard for E2E test?
Mm-hmm. And then they run every single pre-submit through Prow and all of that. Because Prow will boot up a kind cluster we can test against. And so this will help us, because we've had a couple issues where we've gotten things merged into it and they broke the actual implementation, but all of the tests passed. And so I think that was why he picked this up to start working on it. We basically had, when we added in the new front proxy work, some of those pull requests actually broke the core implementation for a little bit there, and we had a bunch of issues that got filed from different folks.
So my conclusion is, let me see, where did they put? They put in the CAPI. So this is okay. This is just the E2E test for control plane or for VC. I don't think this is for VC.
For now, control plane. And then we'll as we continue to merge, because I still haven't gone through and done all the release cycle that's been on my plate for VC. So once we get that in place and have pre-submits for all, we have some of the pre-submits for that, but once we get everything through Prow, we'll yeah, go ahead.
The problem is where Chow is working on switch to kubeadm. I'm not sure if this is the same for how that will change our E2E test strategy. Same thing, because all the CR is gone. I'm not exactly sure what kind of E2E test they are going to write, because I don't hope that they write E2E test based on our current CR, because they are going to be deprecated. Oh no, not even deprecated. They're going to be
removed. Yeah. We can provide feedback on the PR about that and say that there's point them towards our current this doc and the proposal, and basically say, just FYI, this is changing a little bit, so don't go too far. Don't get too far into this.
Yeah, that's actually Yeah, I haven't looked at it. I don't know if they hardcode anything right now, but it looks
Right
like,
now, it's just make file updates. So they're trying to basically get everything prepped for it, and then they'll go and do the implementation.
yeah, okay. That's we need to make an agreement saying that don't go wait a little bit. We are changing it drastically for Intel thing.
Yeah. Hopefully it's not too bad if they want to do that. I mean, at least they'll set up the framework for us, because there's gonna be a lot of physical Go code that does all of that kicks off all the ETE tests. So whatever that looks like as well, potentially that is the same. We just get to re-leverage it and just change the CRs that it deploys, which might help Charles from being able to actually test it a little bit better from a pre-submit side of things. I don't know. I think we can. I want to definitely look at what they've done. I've only skimmed it for like 5 seconds before this call started when I noticed it. So
Yeah, just side question. So maybe Scott knows what kind of ET test for the other copy, the CAPI project do. Do they do a lot of validation tests, or they just, yeah, do they run parts or do anything, or they run any Kubernetes conformance test against that generated cluster? Or what else? So do you know anything more about the ET test?
So there are end-to-end tests that are run on all of the different providers where they do run conformance tests. And they test, for example, upgrades of clusters. So like they'll deploy a management cluster, deploy a workload cluster, then do the cluster cuddle move to see that the move works for a cluster API. Then they'll upgrade a cluster to test the upgrading to make sure that doesn't break, things like that. So there are lots of tests there. There are tests, some of them I believe have tests as well. There are periodic tests of like scaling. So scaling the nodes, because worker nodes and all of that, they want to test the scaling. Ones that have, because they have machines there, there's like machine sets is a feature flag, but that exists within the cloud providers out there for machines and whatnot. That also has its own set of tests. I don't think anyone has tests for cluster autoscaler today, even though cluster autoscaler supports CAPI. But I think that that's basically what's being tested now.
That's pretty cool. So I didn't expect that. Okay, I think the coverage is good. So
Yeah.
hey, I'm also
in
dropping a link
general-
into the chat for this if you want to check out like the unmanaged version of CAPA's tests for them exactly what Scott was talking about there, like the upgrades, how it goes through and tests those kinds of things.
I
If you
see.
want to take a look at that.
Okay, understand.
Yeah, and the other fun thing is that the hope is to get CAPG, the cluster API GCP, hopefully in the relatively near future would be the hope to become the new mechanism that clusters will be spun up for all CI tests in Kubernetes instead of the current terrible implementation or unique implementation. I guess I should be politically correct. So the hope is to do that, and then that would also gain traction for cluster API, which is always great. So yeah.
I love that. That'll be great, because then we could actually test against real clusters, not just kind clusters in Prow. And we could use things like type load balancer to actually make it so that it represents the physical service, and we can address it through. Yeah, that'll be really cool.
Yeah.
Nice. Cool. Anything else? We got 4 minutes left. All right, folks. Oh, you good?
Good. Not in my side.
Okay, cool. All right, everybody. Again, this will be posted to YouTube. Thanks again for all of the fun and good conversations. Charles, excited to see the demo next week. If it doesn't get done, no worries, but I'm excited on all the progress and great work there. See y'all next week.
Okay, bye-bye.